Hi, today's a big day. I want to get into all of the 24 purpose-built tests that I've written for the ALU, and I want to execute those. Now, my limit on video length is about 25 minutes, so if each test takes about 1 minute to execute, including all my commentary around it, I'm going to be right at the end of the video here. Anything that requires any in-depth troubleshooting is obviously going to extend past that. And since I record the intro before I get into the actual video content itself, you're going to know before me whether or not I was successful. If the title of the video says part 1, then it's a train wreck. And if you like train wrecks, welcome aboard. On the other hand, if it does not say part 1 or imply that there's a part 2, then I was likely very successful in getting through all of these tests. Either way, I invite you to stick through to the end because I have something to demonstrate and a question to ask. All right, I don't think we have a lot of time. Let's get into it.
Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey.
Okay, I've been through these first few tests a few times in troubleshooting the ALU, so we'll get through them relatively quickly. I'm going to stick down here in the corner the actual code, and that's because up here I want to put a banner as to which test we're going through. That way, if you decide you want to fast forward through this a little bit, it'll hopefully make a little bit more sense where you land. All right, so test number 1. We're going to add two numbers together and store the result in R1. So the first thing I want to do is I want to make sure that R1 and R2 are in a known good state. So I move the 0 register, pseudo register really, into each of R1 and R2, making sure that these are 0. Now, it doesn't do a whole lot now. This now adds together, making sure that my result here is 0. And that has not worked because I've already got a 1 in the result field. And so we've got our first bit of troubleshooting to do here. Okay, who had train wreck at the first test? Go on, raise your hand. Let's see them. Yeah, I had me getting to at least the 20th test in this video. I'm going to jump ahead here and we'll talk about what I had to do to get this circuit working again. Well, to get this thing stable again, I had to do some pretty invasive things. First of all, I disconnect and hardwired all of these signals leading to the LED. The LED itself has been removed. Same thing up here, I disconnected and hardwired all of the signals that were leading to this LED, and the LED itself has been removed. I ended up actually adding another 6 inverters up here and resetting the timing here for this signal, which is the end latch, or the latch signal for the ALU output. The fact that I had to make changes up here just simply reinforces how fragile this build is and the clock. And yeah, I'm vested in this at this point, but I am going to be making a change to the clock circuit itself so that it's less fragile. I need this to be stable more than I need it to be fast. So a 4-cycle clock is what my solution is, and I will work towards getting that done, but I do want to get at least this section of the ALU buttoned up first before I go down that path. The good news is that all of the signaling is really controlled in the control modules here, so all I have to do is change the clock and how I combine the signals with the actual signaling coming off these EEPROMs, and I will have the signaling I want. But now, with all of these invasive changes, I need to figure out what's broken and how to fix it so that I am no longer chasing issues like I was. And I just noticed something up here that also would be creating a problem, which I did not realize that those were disconnected. Those would control the Z flag calculation. Well, first things first, let's see if I can get the LEDs back for these control signals. And for the record, I'm looking for what breaks the build. Okay, so these signals should all now be accurate. Okay, and I want to make note that my program counter is now incrementing on the first clock cycle as well. Okay, so those are good. I'm happy with those. So the next thing I want to do before I get into plugging more things back in is I need to reset, do a hard reset. I'm going to lose my microphone when I do that. So I'm going to have to stop OBS and restart. So let me reset that real quick. I'll come back with a fresh OBS session and we'll perform the test again. Okay, I'm happy with that. All right, so with that, let's see what that does. Those are good. Okay, back in business. All right, let me reset and we'll retry test number 1. Okay, test number 1 again. Okay, clear R1, clear R2. Not going to do anything. Add those two together and store the result back in R1. Make sure that both R1 and R2 are clear. Set the carry flag. That works. Now I'm going to move this value into R1, and then that forces a no op up there, which is working properly. Move this value into R2. These are alternating bit patterns such that when I add them together, the results are all the LEDs on. That's the add, that's the result, and that gets stored back in R1. Now, my carry flag is set. My negative flag is properly set. The carry flag is not properly set. It should be 0 because I did not actually carry anything. I need to go back and double check and find out what my carry flag would have been. So I can see it as unset there. Okay, so that's high, and that's high. And my output is low. So my latch of carry should be pin 3, is it? I need to pull up a diagram. Okay, pin 3 should be the clock. So on the rising edge of that clock, it should change or latch the data, which the data is on pin 2, which is low. So it should be latching low, and it's latching high. And that is going high momentarily. So my carry flag latch needs to be brought earlier. My negative flag is being latched properly, it looks like. And for the record, I believe that the carry flag is being set because the ALU inputs are being reset as part of the addition because the results are being pushed out onto the bus again. So these two added together will generate that carry. As a matter of fact, if I measure my data up here, it is high. So the question then becomes, do I still need to latch this input? It would definitely remove the latency, but then I've got to contend with the latches here and make sure that I've got enough time for all the propagation. Or do I change the control such that it's only outputting on the low side of the inverted clock? I can't use the high side because one of these has an active high signal. But if I take one of the low signals and feed it with the inverted clock, would that make a difference? And I believe that would, because it would stop asserting out onto the bus at the rising edge. Let's see if I can get that change done real quick, and we'll see what that does for us. So let's reset. And that was correct. That was correct. This is not correct because I need to extend that signaling over. That worked. That did not work because it did latch the Z flag. So my Z flag, sorry, my head's gonna get in the way. Well, it's using the spike clock too. Almost makes me wonder if I shouldn't change these to be based off of after the latch instead of before. I had such high hopes. That could impact the negative flag as well. That's what this brown signal is here. But let's see what happens. That's correct. That's correct. That's working exactly the way it's supposed to, I believe. All right. So test number 1, once more. We'll reset, clear R1 and R2, add the results together, store the result back in R1. Set the carry flag. The 0 flag is still set from the previous add operation. Move a constant. Move a constant. Here's my add instruction. The add is performed correctly. I'm going to latch carry and in, and overflow should not be set. Z should not be set. So this should be off, off, on. Perfect. And then there's a forced no up there, which won't change the flags. All right, test number 1 passes. Okay, test number 2 then is exactly the same as test number 1, with the exception that the result goes into R2. No, it's a different bit pattern that's being loaded. So let's clear out R1 and R2, clear out my flags up here, set the carry flag, move my pattern of bits into R1, move my pattern of bits into R2. Now I'm doing the add. The results should be exactly the same with just the in flag. Perfect. Test number 2 passes. Tests 3 and 4 are very similar to 1 and 2, except the ALUB assert is coming from the fetch register. So these are going to be immediate values that are added to the contents of R1 or R2 respectively, and the results stored back into R1 and R2. Something didn't happen right here. I need to reset and look at that again. Okay. My bit pattern is CCCC added to 3333. What shows up on ALUA is 6633. I'm sorry, that's ALUB. 6633. So I've got something that is wired crossways, and since it's the first time I've used this assert out onto ALUB, it could very likely be in these signals here as well. And it's probably a high probability that they're in these signals just because the previous 2 adds worked over here. So, what the heck is that? Just a little bit of insulation that was stripped off. So low, low, high, high. So that looks good. That's going off to ALUB. Low, low, high, high. Could it be that I got a couple of these backwards? No, they're hitting the bus correctly. These are not correct. Okay, so here's the bus coming in, low, high. So it is incorrect here. It is correct here. Is it correct over here? No, I couldn't have done that, could I? Could I have a problem on this back plane? That's what I'm wondering at the moment. Because the inputs over here, low, low, high, high, they're correct. The outputs over here, low, high, high, low. This pin doesn't feel quite right to me. But low, high, high, low are incorrect. And then I've got on the actual bus, low, high, high, low. Actually on the ALUB being asserted off of here. The input into the bus is correct, the output is incorrect, and everything on the board is incorrect. My problem is going to be somewhere related to those connections. Well, this is a significant train wreck. Okay, so looking at all of my connections for ALU bus B, they all appear to be ordered correctly so that the connections, the network connections to the pins all look accurate. ALU bus B. Well, those do not look like they are crossed, at least not on purpose. I think I'm going to have to pull this register backplane out and inspect it closely because I'm not convinced I don't have things jumped or bridged or exactly what's going on with this. I do believe the problem is on the backplane though. Okay, before I go trying to tear things apart here and do some invasive testing, which is my normal MO here, I'm going to put this on continuity mode and do some basic testing here on the high nibble. Okay, I'm going to spare you this part. I ended up taking everything out, testing everything individually, one at a time, put it all back in, making absolutely no changes other than reseating everything, and it worked. I hate those problems. Okay, I'm reset, found nothing. I don't know what could have been causing that, but reseating all of those connections hopefully did the job. All right, let's walk our way through this. Test 1 is still good. Test 2 is still good. So my pattern here is exactly my pattern here. That looks like it's going to be a good result, and it is, and my flags are correct. All right, so test 3 passes. Test 4 is the same thing, but we're playing with R2. So 3, 6, C5. 3, 6, C5. And C9, 3A. C9, 3A. That looks good. Proper. Test 4 passes. Test 5 and 6 are like test number 1 with a couple of key differences. First, I'm using an add with carry. Test 5 has carry set. Test 6 has carry clear. Setting carry. Alternating bit pattern. Reverse. My inputs are correct. My output is all 0. And that something didn't work right here. All right, so that's likely. God, dare I say timing? Let me re-execute that. Yeah, something's going on. Something's going on here. And somehow it's probably not latching late enough, is my suspicion. Because the carry flag's probably coming into late into the equation. All of these get zeroed properly, but I don't get far enough along is the way I read this. Now I may be wrong, but that's the way I read it. So here's the challenge: is it's getting tough to test now because I'm so far into it that I have to step my way through it. So I'm going to end up jumping my way through this to get to the correct test. But I've got to double check and make sure the carry flag is coming in at the right time. Okay, looking at this, carry is coming off the outputs of the latch here. And just for giggles, I'm going to move them over to the input side because I believe the latch is not happening in a timely manner for what we're trying to accomplish here. Okay, here's my alternating bit pattern loaded. That looks good, that looks good. But I still didn't quite get there. Although I got one extra bit completed. All right, timing issues. Let's take this back to where it was. Of course, I just changed the timing of all of this. Because I made this change over here, I believe I'm causing my problems here. So I may need to change the timing in which this is latched. I gotta think on this. It dawns on me. Two of these things are not like the others. Specifically, both the carry flag and the negative flag are taken directly from the results of what goes on in the ALU adder itself. The N flag or the negative flag is simply the most significant bit extended up to the flag's register. The carry flag is the result of the last bit of the addition, the one that does not show up in the result because it overflowed out into the carry flag. with that understanding, both of those values really should be latched at the same time the ALU output is being latched. Now, over here, that takes care of explaining kind of what the problem is. The solution, on the other hand, is over here. This latch over here for the ALU adder, I believe, is currently an inverted clock, ANDed, it's an 08, ANDed with the signal so that I get a rising edge partway through. I should be able to change that to be an uninverted clock and NAND that. I need to double check my truth table for that. But I believe I can do that in such a way that it's typically high, goes low right before we want to latch, and then returns back high. So that being said, the C flag and the N flag, the latches associated with both of those, really need to be NANDed not with the inverted clock or the spike clock, but this delayed clock that is now currently driving the ALU adder latch, or the ALU latch. I need to pull some wires just so that I can test that, but I need to also double check and make sure that I'm pulling the right things, because the Z flag, the V flag, and the L flag are all calculated from the result of the add, and therefore will take a little bit longer. I don't believe those can move. Those are going to have to remain as they are. So I've got to be somewhat surgical in what I do here. So let me figure out which signals exactly I'm dealing with, which clocks I'm exactly dealing with, and figure out how I'm going to improve this over here. And I'll be right back with some changes. After checking, bits 4 and 3 are the ones in question. Now bit 4 comes all the way over here to this gate in the NAND. Bit 3 is this gate, so I will have to replace these two wires with something a little bit longer. All right, and so the last one, I'm just going to grab this one, and I will just hop it at this point just for testing, and I will put it here. So this one here is right before the inversion that this line is on. If this works, I will take some time to clean this up, obviously, and even sort out this gate over here. Okay, let me jump right to the test in question. And of course, I've got to come back around and make sure that everything actually still works properly. Okay, so here's my move of my immediate value into R1, different value into R2, and then here's my add with carry. That's correct. I've got my 0 flag and carry flag, but my carry flag still goes away. And I thought for sure I had this figured out. And things went from bad to worse after that. I never actually got the carry flag working properly. And it dawns on me, well, I've been thinking about it for some time. It's time to take a step back away from the build and re-look at this and reevaluate how this is going, because it's obviously not going well. I'm not an expert. I never purported myself to be an expert. I'm learning here as I'm putting this together, and sometimes you got to learn how to make mistakes too. This is clearly one of them. So this isn't the video I intended to make when I set out to do these tests. I really had higher hopes for how this was going to go. And I had faith that the first 18 to 20 or so tests were going to be really, really good. So I need to take a step back away from the build and start thinking a little bit about how I can think through the things that I want to accomplish and try them out in a manner that's not going to be committing them to hardware right out of the chute and testing it. To that end, I've actually started working on an emulator, and I'm going to throw up in the corner up here a running demonstration of it. Now it's not anything fancy. I don't have many components built out, but it does represent the 4-cycle clock that I am intending to replace the current clock on this build with. And I believe that's going to help me reconcile all of these timing concerns. So I need to take a step away from the hardware portion of this and start emulating some of the stuff that I'm considering. So with that, I have some questions. One, would you like to see me iterate my way through the emulator and how things are going to be pulled together? It could be a very big departure from what you're seeing now, which is a lot of hardware, breadboards, and PCB work. B, I have a choice as to where I can start, and I don't know if anyone has a strong opinion on where that should be. I've got a clock. It's not fully vetted yet. I'm working on getting that totally wired up the way I need it so I can step my way through. But then I've got 3 places I could start after that. I could start with a control ROM build. I could start with the register build. I could start with the ALU build. Now I've got my opinion on where I should start. In the absence of any strong opinions helping to guide me, I'm going to go with my own. But guys, I am not giving up on this. Not at all. I have every intention of coming back around to the hardware build, and I have every intention of completing this. I have lots of things that I still want to do with this. But it was always on my radar. It was always part of this project to build an emulator. What wasn't part of the project was building it before getting the hardware actually operational. My intent was to get the hardware done first and model the emulator after the hardware. Turns out I got that backwards. I think I'm going to have to get the emulator done first and model the hardware after what the emulator's doing. Now, up on the demo that you're seeing up here, the green LEDs that are pictured up there is the counter of the 4-state clock, or not the counter, but it is the change of each of the states of the 4-phase clock. And then the blue LEDs actually show you how each of those would be interleaved with each other, basically 90 degrees apart. So that's what I plan on putting into hardware, and I am likely to be able to start that relatively soon, and I want to be able to get there as soon as I can control it and single step that clock. Anyway, if you have any opinions, let me know in the comments. Certainly I feel quite down at the moment because this is, like I said, not the video I intended to make. I had plans to get a little bit farther along before I took this step back, but it's just not going to work. Not in its current incarnation. So I need to salvage what I can and redo what I have to. And I need to know how I'm going to do that. Anyway, with that, see you soon.